Hello, this video is documented for ME-307 Machine Elements 1 course. This video is a demo lab video. We will start our demo video by talking about critical loads on struts. As you know, as you learned from ME-307 course, the columns can buckle under some critical loads. These loads can change by altering the end conditions of the support. Here we have a demonstration test setup for this 5mm rod. As you learned from the course, critical load depends on the end condition C and the modules of elasticity of the material the column made of, and the moment of inertia divided by square of the length of the rod. Here we have the diameter of the rod 6mm. Here the pivots, both ends are supported. Take the C as 1, and we have the length of the rod as 965mm. So we can calculate the critical load to be applied on this column will be 134.8 Newton. This is calculated load. Then we will see if this rod can buckle under this much of load. Here we have some dummy loads, each of them 50 Newton approximately. We will apply 50 Newton first. As you can see, we have no considerable buckling on the rod. If we disturb the rod transversely, it comes back to original position. As you can see in the demonstration here, when we apply some load, transverse load, it comes back to original position. Then we increase the load to 100 Newton by applying another 50 Newton. As you can see, there is no considerable buckling on the column, this rod. Now we will add another 50 Newton to increase the load 150. As you can see, the column shows a considerable amount of buckling behavior on the transverse direction. So the beam or the rod cannot come back to original position by applying the transverse load in the opposite direction. So what happens if we change the end conditions here and here? We will show you on another demonstration setup here. Okay, this demonstration setup shows you how applied critical load change by changing the end conditions. Here in this beam, in this column, we have both ends pivoted or single point supported column. We apply some small load. Here you can see the deflection curve here when it buckles. If we change the end conditions, one end is guided or fixed. One end is ancaster supported, ancaster fixed. Another support is pin supported. If we apply the load, I don't know if you can observe, but I can easily buckle this beam while I should increase the load by my fingers here. You can see the buckling curve appears here. As you can see, the radius of curvature and the deflection shape of the beams are pretty different. And if we have both ends fixed or both ends Lancaster supported, we should increase the load dramatically, and you can see the deflection curve, which is very different from previous two. You can see. And if we change the support, one end is free, the free end here, as you can see, and one end is fixed. We should much higher load. We should apply much higher load here. The buckling of the beams or buckling of the structures are very important when we design, for instance, a steel construction. For example, if you're a structural engineer, you should consider buckling or elastic stability of the steel construction. Or in any other case, for example, if you are designing a heavy machinery and you have machine chases, for example, your machine chases is highly asymmetrical, for example, then you should calculate or you should consider the deflection or buckling behavior of the different points of the chases in order to reduce the angular misalignment of the shaft support or bearing support. So this phenomenon is very important when we design steel constructions or heavy machinery, we can say. In this section we will see mechanical springs and their mechanical characterization. The mechanical springs can simply be divided into three main categories. These categories are mechanical springs that should work against compressive load like this, for example. This is weight will change minus sigma to plus sigma. So after this procedure will be repeated maybe 100,000 to a million times of revolution. After the for example 1 million times of revolutions, the specimen will break down